What if the most important photograph in human history was taken by a machine on another planet, entirely by accident? On October 4, 2025, NASA's Perseverance rover captured a routine image of the Martian horizon, but hidden in the grainy pixels was something that, well, defied all explanation. A structured, massive object from interstellar space that behaved like nothing we have ever seen. Within days, NASA went silent. The images were archived, and the data stream stopped. Let's explore this together.
The accidental photo.
It all began with a ghost in the Martian twilight. On Sol 1643 of its mission, the Perseverance rover performed a routine shutdown procedure. Its right-side navigation camera, NavCam Right B, an engineering camera designed purely for hazard avoidance, nada van zal dat die bouwde Gerard Steels kan aan Erdebusoin, so berada broer trod and readed. The resulting image, timed at 1832 UTC, should have been unremarkable. Instead, hanging in the upper right corner was a faint blur, no brighter than magnitude 8.7, where no star should be. At NASA's Jet Propulsion Laboratory, Dr. Justin Mackey, the lead imaging scientist for the mission, initially had his team flag it as a sensor artifact, but the blur persisted over 17 consecutive 1-megapixel frames, shifting just slightly against the background stars. Before the mission team could formally investigate, the image was uploaded to NASA's public archive. It was there that the discovery truly exploded. Amateur astronomers, using publicly available trajectory data, realized the blur's position perfectly matched the predicted path of Interstellar Object 3, I/Atlas. The signal-to-noise ratio was a mere 4.2, almost statistically invisible, yet undeniably real. A geology rover, by sheer chance, had just become the first observatory on another world to photograph a visitor from the stars.
Confirming the visitor.
How do you confirm an impossible photograph? You bring in more witnesses. Back at JPL, the realization sent a shockwave through the control room. Engineers led by Dr. Swati Mohan, the famed guidance and control lead for the Perseverance landing, began to reconstruct the rover's exact orientation. They confirmed the camera was angled at an azimuth of 281.4 degrees, precisely toward 3I/Atlas's predicted location. The object's distance was calculated at 0.1937 astronomical units, roughly 28.9 million kilometers from Mars, and its calculated interstellar velocity was a staggering 55.2 kilometers per second relative to the Sun. The case was strengthened when planetary scientists called for backup from orbiters. The Mars Reconnaissance Orbiter's HiRISE camera, squinting at the edge of its capability, registered a faint 0.02% dip in background luminance in the same quadrant. The European Space Agency's Trace Gas Orbiter confirmed a similar signature. This wasn't a glitch. The internal log for the Sol 1643 image was updated from anomaly confirmed to interstellar target lock. As Dr. Mohan's team noted, a machine built to look down at rocks had accidentally achieved a deep space observation that telescopes on Earth, peering through our thick turbulent atmosphere, could never have managed with such clarity.
Reconstructing the image.
With confirmation in hand, the real work began. At the University of Hawaii, Dr. Karen Meach, a renowned expert who led the characterization of the first interstellar object, Oumuamua, was brought in to consult. Her team took the 17 raw NavCam frames and began a painstaking reconstruction using a Lucy Richardson deconvolution algorithm, a process designed to sharpen blurry images. They expected to see a slightly sharper smudge, but what emerged was stunning. The blur resolved into a distinct, elongated object with an angular size of nearly 50 pixels, translating to a physical length of at least 4 to 6 kilometers. But the shape wasn't the strangest part. An analysis of its light curve revealed a physical impossibility. As Dr. Meach explained, 3I/Atlas produced an inverted phase curve with a positive slope of plus 0.03 magnitude per degree, meaning it grew brighter as the viewing angle increased. This phenomenon is unheard of in natural bodies, suggesting its surface wasn't just reflecting light, it was somehow gathering and redirecting it in a non-Lambertian way that, honestly, defied the laws of passive reflection. It was as if parts of the surface were actively brightening in response to sunlight.
Light defies rules.
Why was the light from 3I Atlas behaving so strangely? The answer pointed to a surface unlike anything astronomers had ever encountered. Using polarization data from the orbiters, a team led by Dr. Stefano Bagnulo of the Armagh Observatory, who is, by the way, a leading expert in astronomical polarimetry, analyzed the object's optical signature. Normally, when sunlight scatters off comet dust, its waves align in pretty predictable ways. But 3I Atlas broke every rule. Across all observations, it displayed the strongest negative polarization ever recorded, measured at a constant -2.77% at a 700 nanometer wavelength. This reading was so extreme that, honestly, peer reviewers initially flagged it as an error. For comparison, the famously unusual comet Hale-Bopp never exceeded a negative polarization of -2%. According to Dr. Bagnulo, these readings implied the particles surrounding 3I Atlas weren't porous ice grains but were dense, irregular, and likely metallic structures that scattered light chaotically. The data even hinted at microscopic facets with high refractive indices, as if the object was shedding a cloud of manufactured debris or crystalline shards instead of a natural coma.
The backwards tail.
The mystery deepened when high-contrast images from the Mars Reconnaissance Orbiter revealed another impossible feature. Emerging from the sun-facing side of 3I Atlas was a faint narrow streak of light extending over 80,000 kilometers. It wasn't a tail pointing away from the sun, but an anti-tail pointing directly toward it. Comet specialists like Dr. Geraint Jones from UCL's Mullard Space Science Laboratory have seen anti-tails before, but they're usually optical illusions caused by viewing geometry. This was no illusion. Its stunningly low width-to-length ratio of 1:15 persisted across multiple observations, confirming it as a real, physical structure. Spectral analysis showed it was composed of micron-sized silicate and oxidized metal grains, with a density of 2.8 grams per cubic centimeter, which is honestly far too heavy to be pushed by solar wind. This was a collimated beam of matter being actively ejected forward. To achieve this, simulations by Dr. Jones's team showed the nucleus had to be extraordinarily dense and cohesive. 3I Atlas wasn't a fragile snowball, it was a monolith projecting a beam of matter into the sun, a behavior with, honestly, no known natural precedent.
Solar blast.
Just as the world's astronomers were grappling with these anomalies, the sun itself intervened. On October 6, 2025, a massive X9-class solar flare erupted from active region 3492, launching a coronal mass ejection. Dr. Nicola Fox, head of NASA's Science Mission Directorate and a top heliophysicist, confirmed its trajectory. The plasma cloud, moving at over 1.6 million kilometers per hour, was on a direct collision course with 3I Atlas. Around the world, observatories saw the object's brightness spike for 6 hours, and then it vanished. The signal collapsed into silence. The proton flux at Mars jumped to over 1,000 proton flux units, a severe S3 class radiation storm. A CME of this magnitude would have completely disintegrated a normal comet like Ison in 2013. For days, astronomers feared the object had been vaporized, taking its secrets with it. Had humanity's first close look at an interstellar traveler ended with its violent and perhaps predictable destruction at the hands of our own star?
The disappearance.
For 16 agonizing days, 3I Atlas was gone. Every scheduled search window from every major observatory came up empty. It was as if the CME had simply erased it from existence. The timing was too perfect to be a coincidence. Then, a single ghostly echo emerged. Buried in the logs from the European Space Agency's solar orbiter, Dr. Daniel Miller, the mission's project scientist, found a non-correlated event, a half-second pulse of polarized light moving opposite the CME's flow. The pulse had a distinct energy signature of 0.2 GeV, too powerful for a simple reflection and possessing a coherence that suggested an artificial origin. Its origin point aligned with the last known vector of 3I Atlas to within 0.2 degrees. This was the final, fleeting glimpse of the object as it was engulfed, suggesting it hadn't just been hit, it had responded. The photograph from Perseverance on Sol 1643 suddenly took on a new, solemn meaning. It wasn't just the first image of this visitor, it was the last image taken before the sun itself struck it down.
Impossible mass.
Just when everyone had given up, the tracking programs got a hit. 3I/Atlas had survived, but the real shock was that its path hadn't changed at all. Despite being hit by a massive CME and seemingly venting material, its trajectory remained perfectly stable, with a deviation of less than 1,000th of an arcsecond from its predicted course. At Harvard University, astrophysicist Dr. Avi Loeb, famous for his controversial theories about Oumuamua, argued this was the smoking gun. For an object to withstand that blast and show no recoil, it had to have an astonishing amount of mass. The models all produced the same result. 3I/Atlas had to weigh over 33 billion tons, or 3 times 10 to the 16th kilograms. Its calculated density was 7.8 grams per cubic centimeter, the same as solid iron. It possessed the inertia of a small moon. As Dr. Loeb pointed out, this was an astronomical paradox. A body massive enough to ignore the sun, yet delicate enough to shed a trail of dust without being nudged off course. This wasn't just an anomaly, it was a violation of Newtonian mechanics as we apply them to comets.
Martian chemistry.
As analysts dug deeper, spectral data from the Trace Gas Orbiter delivered another shocking revelation. Faint but unmistakable signatures appeared in the light from its halo iron oxide, silicates, and perchlorates. At Caltech, Dr. Bethany Ehlmann, a leading expert on Martian mineralogy, initially assumed it was contamination from Mars's atmosphere, but ground-based telescopes soon reported the same pattern. The data showed a deep absorption band at 860 nanometers, the unmistakable, spectral fingerprint of crystalline hematite. After calibration, the object's dust showed a 94% spectral match to the regolith of Jezero crater, where Perseverance itself was driving. The conclusion was unavoidable. The chemistry didn't match an icy body from deep space, it matched the crust of a terrestrial planet. This reframed everything. 3I/Atlas was a planetary fragment, a piece of a long-dead Mars-like world from another star system expelled by some ancient cataclysm and carrying the exact same mineralogy as the world now observing it.
Geometric patterns.
The final clue was hidden not in chemistry, but in pure mathematics. Once the full orbital path was reconstructed, a pattern emerged that defied all probability. As pointed out by Dr. Corin Baylor-Jones of the Max Planck Institute for Astronomy, its trajectory had an inclination of just 2.1 degrees relative to the ecliptic plane, where all our planets orbit. A random interstellar object should have a high arbitrary inclination. Furthermore, its path intersected the orbital corridors of Mars, Venus, and Jupiter in a sequence of near-perfect harmonic intervals, a coincidence with odds calculated at less than 1 in 10 million. Then came the most chilling alignment. Tracing its vector backward, its origin was just 9.3 degrees from the 1977 WOW signal's source in Sagittarius. Dr. Baylor-Jones noted that the pattern felt uncomfortably non-random. It looked less like a cosmic encounter and more like planned choreography, moving through our solar system as if it already knew the way, a ghost following a predetermined map. In the weeks that followed these discoveries, the public data streams went quiet. Mission logs from Perseverance were marked data under review. No new coordinates for 3I/Atlas were released. It wasn't an overt act of censorship, but something far more unnerving. Institutional silence in the face of data that did not fit any known model. The image from Sol 1643 is now known quietly as the frame that shouldn't exist. It is the last confirmed sighting of a visitor that defied physics, survived a solar blast, and followed a path that looked unnervingly intentional. What did Perseverance really capture on that lonely Martian evening? Let us know your thoughts in the comments down below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the universe's greatest mysteries. Thanks for watching InnoVision Tech.